All right. We're going to be looking a little bit at chromatography and distillation. And I thought this would be a little bit better way of going, of looking at some animations and then just discussing them as they go. So this first one looks at chromatography from what's called a column standpoint. So you have a couple different areas of any type of distillation that occurs. You have a mixture of products, and we're going to load this into what would be considered the column chromatography. The stationary phase is kind of the main solid component that would not be moving as we put what we're trying to separate into the column. Now, in order to get this mixture to move, we add a mobile phase, some kind of liquid that has some attractive forces. Now, as these occur, these have different attractive forces for the different components. They're going to go at different speeds based upon their size and attractive forces. You can see these are very lowly attracted to the mobile phase. So each of these are able to be individually separated because these would come out at different times and be able to separate it based upon its physical properties of attractive forces. You can change these based upon what you have for the stationary phase. The stationary phase, if you have much larger particles, if you have tinier holes for them to go through, and again, we're still talking atoms and molecules, it'll take longer for larger structures to go through smaller gaps. So that can be one way to control the speed at which you would separate these. Now, one useful part of this is that this is used to separate these and actually use them in a functional manner. So you'd be able to now use this blue, this yellow, this red in order to do your own components. So this would be taking a mixture and being able to utilize it in some further chemical procedure. Now, thin layer chromatography, also known as paper chromatography, looks at it from a very simple analytical standpoint. So you have a whole bunch of mixture of products, tons and tons and tons. We won't be able to see it all very clearly. It'll look like some brown goop. However, if we're able to take this out, thinking of our stationary phase being our paper and our mobile phase being the solvent, it'll be able to push out those different components. However, we can't utilize these different components. This is more for a qualitative measurement. So you have our thin layer plate being the stationary, mobile phase being that. It goes up through capillary action, and you can see the separation over time of the different components, and that's based upon its polarity with the mobile phase. The stationary phase, the paper, does have some added effect in separating them out, but this really does show a very clear delineation between our 5 different products based upon what we can see. So some of the original maintains because it's kind of gets embedded in the paper, but we're able to see this separation to see that there's 5 different components, and that the one that has the strongest attraction to the mobile phase would be found here. The lowest level of attraction is found here. Now, there's also a difference in size. We could also maybe consider these to be also very light in size and very heavy in size, when something in the middle might be different. So there's a difference between of what attracts through by size of the particle and attraction to the solvent. So if you wanted to go through the fastest, you'd want it to have the least attraction to the least attraction to the thin layer and most attraction to the solvent or mobile phase. So this is how we can separate it qualitatively in order to get through the rest of our ideas. Now, distillation is another way to separate mixtures. This will show you the simple distillation process. Don't need both. So if we have a mixture of A and B, we want to separate them out to be separate. This is another way of utilizing components of liquids. They need to have very different boiling points, because what we're really doing is we're going to look at boiling, adding kinetic energy, change from a liquid to a gas. And when that gas comes out, we're going to need to have some way to collect it. and essentially cool it down to change it to a liquid, or we can collect it in a separate vessel. Unlike the column chromatography, that didn't change phases. That was always in a liquid phase. This is changing it to a gas, which could have some components that could be difficult if things start to break down at lower temperatures. But generally, you wouldn't use this as a part of that. So there's three major components that you have from this. Distillation flask, what you're going to be putting your mixture in. Then you have a condenser, a way of cooling it. This is a very complex piece of glasswork that has a kind of open area for water to flow through and cool down, and a collection vessel where you're going to collect your separations. And you'd have several of these, or I guess in this case they only have two because of the fact they're separating two different things. Way of providing heat, there's different types of heat plates. You generally would not use flames, but you could. Then there's a three-way adapter with a thermometer so you can measure the temperature, because you want to maintain that this temperature be above the boiling point of one but not of both components. So you have the mixtures in here. Of course, they're not separate like that. They're mixed together, giving a kind of overall color of the both combined. And that mixture A is 70 degrees Celsius, B is 100 degrees Celsius, kind of like ethanol and water. You'd want to turn up the heat, get it going, and that when you get to that temperature of what's in the flask, that's going to vaporize. Get it going, get it boiling, evaporate. You have it condense up in, or you have it collect in here, increasing the thermometer, the air temperature here. It's going to increase, and then as it slowly moves into here, this constant water running in and out is going to have components in which it's going to cool down the gases that come throughout here. Slowly, slowly, this would start to condense down and cool down, in which it would be caught in your receiving flask, in which that would be all of the first component, because this would be carefully kept at under 100 degrees so this doesn't boil off. Now it says essentially this would be completely done. However, that's not necessarily true. There's going to be some that are going to vaporize here and then condense. So this is going to be a pretty pure mixture, but would need further distillation in order to get it more purified. This is why you see on some liquors or alcohols, they say like triple distilled, because they've gone through multiple processes in order for getting it to be more, more pure, less of other contaminants. So we've seen what can happen when you have one thing there. But what happens when you have multiple mixtures, multiple liquids mixed together? Crude oil is a very classical one called fractional distillation, where we use the ideas and boiling points of each of these. So normally hydrocarbons, the longer they are, the more that they're going to have as far as attractive forces, meaning they're going to have higher boiling points. So this is used in order to separate this out. We're going to take a little idea of a 3D simulation. So you've got your crude oil, and you're going to want to heat it up. So as that occurs, very high temperatures, you're going to create vapor. And what occurs in each of these layers is you have different areas that you're going to have different things condense at. So at the bottom, when this hot vaporized crude oil comes in, it's going to start to separate and continue up. So at the bottom, it's all becoming vapor, and that this vapor is able to travel through each of these vents. And at each of these levels, you have different substances with different maximum or different boiling points. So once they cool down, they're going to condense. So this area is going to be around 70 degrees or lower. This is 120 or lower, 180 or lower, 260, and so on. So the things that go up are going to start condensing when they get cool enough. Otherwise, they're going to maintain vapor form and continue to rise, because hot air or hot gases rise over cool ones. So this is going to then collect and then kind of be siphoned off into the different barrels and be able to be processed even further. as we can see, this kind of constantly occurring, and that there's going to be different amounts of each of these. Lowest boiling points at the top, highest down at the bottom. And again, which separate into our different substances. So let me know what kind of questions you have about distillation and chromatography, as you're going to be having these on your AP exam in a sense of this is a way we can separate different substances. And again, with distillation, we can use those components. With chromatography, we can use those components if they're separated out and taken out, much like distillation fractions are. If it's just paper chromatography, we're just seeing that there's a difference between the substances at the top and the substances at the bottom and giving us some ideas of their physical components. Come in with your questions and I'll talk to you later. Take care.